you. But
Perfect, because my other computer makes no sounds.
it works perfect.
Okay, good.
Okay, so I guess it's time to start. This is an official IETF meeting for the working group SCHC. I guess if you joined, you know exactly what you're doing. As usual for the IETF, the IETF best practices apply. There were a lot of discussions on the IETF mailing list recently about what the chairs would say about IPR. And there is no definitive language for what we are expected to say at the beginning of a meeting. But basically, the whole idea is if you're aware of IPR that has not been discussed, that is undisclosed to the people participating to the meeting, either you decide to refrain from proposing the idea, or you have to announce very soon, as soon as possible, that there is IPR associated to that idea. And this is also true when you publish a draft. Ideally, you would announce the IPR with the draft 00, and anyway, the chairs will ask you when there is an adoption for a group document. Probably doesn't have to be, but it's a practice. And then in the end, the shepherd will definitely ask you if there is any IPR. And then there's the anti-harassment procedures, which don't really apply on interims, but you have to be aware that you have to be civil with the members of the group and keep the discussions to technical aspect, and don't start getting angry or saying bad words to people. That's not acceptable at the IETF. The agenda for today is not completely full, but we have this big habit of talking more than the time we have. So we have basically 50 minutes allocated. I have slides for everything, but for the tokenizer-based compression, and Chaim does not seem to have joined today. So I'm not sure that we will have this tokenizer-based compression discussion. Yorgos is actually giving a course till 4:30 CET time as proposed here. So that's why his slot is late. And anyway, if we are ready before that, we'll have to wait for him to join for the FAQ discussion on SCHC. So since last interim, we have made this call for adopting a document which was initially presented at ITERIA for the IP protocol number for SCHC. We are still waiting for Bob, for the authors, to publish the document as a draft IETF SCHC document after the adoption. So we have contacted them and we'll try again. So maybe they're just not available right now. We will discuss the OAM draft, but today Alexander cannot be with us, so we defer the discussions on the OAM draft to the next interim 2 weeks from now. Workgroup status. So we had a number of documents which were refreshed. The architecture was refreshed, thanks to Anna for the most part. And we'll have a discussion by Anna on the SCHC architecture document and the deltas that were added to this document. We have also new versions or new document with the zero energy device. So this is already a version 01. And the new document by Yorgos about the forward error correction. And we already had a number of discussions, peer-to-peer discussions. So I hope that Yorgos can present all that to the working group, like I said, after he's done with his teaching today. And in terms of milestones, we are not very well. So we have done the November milestone of adopting SCHC, the IP protocol number, the SCHC protocol number. It's still an open. I put a question mark on the same topic for the March 2025 request for publication for 2 reasons. The first reason is that it's a very simple draft, so maybe if we work on it, it won't take a full year to make the request for publication. That's on the one hand. And on the other hand, we have no contact with Bob for a while, so I don't know exactly what's his aim is for this. Certainly, we could take over if Bob doesn't want to work on this anymore. Then, like I said, the OIM draft we'll have to discuss with Alex and all the others, the authors. As you know, Dominique is working in dotted line on the IETF now and leaving his chairmanship at the Raw Working Group. So we'll see how we can evolve and work on the OIM draft. And then we expected that by the end of last year, we would have the FAQ document ready for adoption, and we just have the 00 now. So we are a bit late on the 2023 milestones. For now, I suggest we live with it and see how things progress before we try to provide new dates. And so with this, we'll go back to our agenda and start with the discussion on the architecture. So Anna, I will present the slides. I would appreciate if somebody else can go and contribute to the minutes, since Anna is our biggest minute taker. So I would really appreciate that's one of the online people, Laurent, Marco. You could help on taking the minutes for the discussion on the architecture. And Anna, it's your call. I can present. I can throw the slides for you and transfer to you, or I can move the slides for you, just as you wish.
No, you can move the slides for me.
Okay.
So, hello everybody. We have submit the new version of architecture. With all the discussion we have already done some interims ago. So please next slide. So this new version is number 2, and we have introduced a terminology section where we have put all the terms that we have discussed, a set of rules, instance, and so forth. You will see it when you will read it. And also we have introduced check header, the stratum for check header. And the stratum, perhaps we need to discuss a little bit today, is what we call the last meetings, the check layer. But we prefer to call it the stratum because it was a very little confusing about the OC layer and the check layer in the middle of these OC layers. So to avoid this confusion, we decide the authors to call it the check header stratum. And then there is the same thing that the check layer, and you in this check header stratum you have the check header and the check compression data. Then we have the discriminator that will help us to identify the instance in the check stratum, and then the set of rules in each instance. That will give us the different rules that we can use at this time. We have also introduced the management packets for check. So next slide, please. So I give you one example for what we have done. Hopefully it's clear. So for example, we receive a check header in down here now. It says check header plus a check compressed data. The check header could be an implicit header where is empty, there is nothing, as in LP1, or there will be some files like identificator and SCHC or something else. It depends on the application or what we are doing. And the check compressed data is the 8724 definition of the check compressed data. So it's a check packet. And when it arrives to the stratum, it will be identified by the discriminator. And once it is identified, the check parser will need to know if it's a management packet, if it's a fragmentation packet, or if it's a compression packet. And once it has identified with the rule ID, if it's one of these 3 possibilities, it will do the management in the set of rule, it will do fragmentation in the fragmentation parser, or it will send this after fragmentation or without fragmentation. It will send it to the compression decompression, where it will choose one instance of the compression, because we can have different packets of different instances of SCHC compression in the same stratum. And once it identifies with the SCHC header the instance of in the SCHC stratum, it will decompress the packet with the set of rules of this instance, and it will send it to the upper layer. And so far, in each layer, we will have this, again, this discriminator that will be, for example, the IP address or the ports or something else. It is something that is outside the SCHC header or the SCHC packet too. So next slide, please. So we have defined the architecture.
I'm sorry to just cut you a little bit, but when you said that each layer, I'd like to go back to what you said, because you really meant this new term stratum, meaning that this process that we have in front of us can happen several times. You can have different cuts in the packet. Each cut is what we call stratum, and obeys this process that you just described. The confusion with layers is that we want to avoid, is because you don't have necessarily to match what SCHC compresses is with one stratum with the operation of one of the OSI layers. You can compress a subset of the layer, you can compress several layers at the same time. So the SCHC stratum does not match the bits and bytes that are operated by different layers. That's why we call it stratum. And like, as you said, it's just a new term that we propose, and we're happy to discuss that term on the mailing list. But basically, when you said at each layer, you meant at each stratum. It's just because we used layer before. And Laurent, you wanted to say something?
Yes, if you come back to the previous slide, please. Yes, so no, I think it looks maybe very complex when you see this drawing, but the implementation is very, very obvious, because we don't touch to compression or fragmentation. And what we need for each part or each box in this stratum is a different set of rules. So it means that all the mechanism remains the same, but we apply a different set of rules on each box. So you may have, for example, the SCHC header that can be empty, like in this example. So you don't have any set of rule, and you go directly to an instance. And in fact, it's what we are doing. So we are not breaking what we have already defined in SCHC or in implementation. It's just a way to generalize it. And another point is a discriminator that maybe should be more discussed, because it can be applied on different places, but it's something external to SCHC that allow you to distinguish which stratum you are going to use. So it can be implicit, like in LP1, or it can be source and destination address, like we can have in 6LoW.
Thank you to both of you. So to continue, I hope this will be more clear. That's why in this slide will be a little bit difficult, because here we show the stratum as a layer, but it's a stratum. And we use the different brackets to show the compressed, the encrypted, and the optional. So for example, between the IP layer and the TCP layer, or the transport layer, sorry, the transport layer and the internet layer, we put an optional SCHC that perhaps will not be used very often, but we can do it to separate these two layers, or to put it all together in one stratum. And then perhaps we will have a security layer, but perhaps not. So it's an optional thing that we can do. And then we have the application layer, where again we can use encryption or not, and that's the optionals in the curly brackets. So in this figure we show the where check can be applied, but it's not mandatory that to apply it in every OC layer. So and then in the device, in the application, again it's the same thing. And in the middle we have the network gateway that only goes to the transport layer. So this only to say that this is the first idea of check used in every layer and in every layer. And instead of thinking about a layer, it will be an stratum that englobes each OC layer. I hope it's clear. So next slide, please. So another thing that we have defined, mentioned, is about the sheet header format that define the stratum. And in this format is an open format. It's not defined. You can include what you need for the stratum. At least we need the ID and the SCHC, but not only. Perhaps you don't need the SCHC. Perhaps you only need the ID. Perhaps you need something else. So you can define the header format as you need it. And again, we will use for the compression of this header, we are using the compressed header format of SCHC, rule ID plus compressed residue, as we have defined in 8724. We have not changing the compressed header format for SCHC header format. Next slide, please. And then the next steps, we think that we need to discuss about the set of rule identification to know which set of rule we are using in each instance and for each stratum. And the rule format for the new ads we have already introduced in OIM draft, in flow draft, and perhaps some other things that you are thinking about. I look at the agenda and I'm now thinking about the FEC also, the payload, why not? So how to add this in the rule format. That's all for me. If you have questions.
Laurent, yes?
Yes, if you can go back to the architecture, to the stratums, previous one, please. Something we have to investigate also is the M arrow that we have that is for management. So the idea is to send core conf to manage these rules, for example, to change value or to set up some rules. And so here, so I think we need a discussion on that. So in my point of view, when we go to the MRO, we have some basic compression rule of COAP and maybe OSCORE or DTLS to send core conf. And we can imagine to have very simple addressing scheme in IPv6, for example, 2 link local addresses that are both ends of the management on each part, and then so we can compress very strongly all IP and UDP and COAP headers and send the core conf information. So
I have one comment, Laurent. Do you think we need to discuss this in the architecture draft, or we need to create because architecture draft is informational? Do you need a new draft for define this core conf information?
I don't know if we need to discuss it. So if it's just to describe some things that already exist, it can go to the architecture. But maybe you're right, because we defined a new nature of rules, because we have compression, fragmentation, no compression, and now we have management. Management is like a compression rule. but will carry management, and only this one will be allowed to manipulate the set of rules.
Yes, and there will probably be a different code path with some security, etc., to allow those frames before they are uncompressed and then applied. So probably there is the fact that we segregate them allow for that different code path.
I'm thinking that perhaps this management thing could be good with the Bootstrap, or do you think it's different?
For me, it's not on. I don't think it can be Bootstrap. It can be Bootstrap, for example, a device that start and say, "Give me my rules." Well, that's my name, that's my identifier, and this is what you say that we have to identify the rule
Hmm.
in maybe an uncompact and compact way. So what we see is that the device, the category of the device, maybe the layer, the stratum we are using, because nodes can have several things. So here we have to see how we can apply this in rules, a set of rule identification. And so then I think there is the other thing is that, for example, you in the flow draft, then you can modify some values in the set of rule, and this is not Bootstrap; it's operational things.
Yeah, but I think it's part of also to access control. How can I modify things in the set of rules?
Yes.
Mm.
Yes, you have the access control to allow for it, and you have the attributes to represent some of the data that the management can change. For instance, the management can help you find the set of rules, but then there will be some information that are necessary to instantiate those rules that are not part of the rules, but that are attributes. For instance, your IP address, the destination IP address, whatever. Uh, which could be represented as $IP, and you have to instantiate that to a change in the rule to change the dot into I don't know 2001 column blah. So that sort of operation is also management. It's acting on the attributes, but when you change the attributes, you impact effectively the content of the rules once they are instantiated. So and all this goes through management. Okay, we are at the half of the hour. That's more than the 10 minutes we had, so I guess
Sorry.
it's time to move to the next topic.
Thank you.
Laurent, you're next. There is this presentation on the lab.shake. Is that okay for you?
I didn't hear your question, Pascal.
I'm sorry. Are you okay to discuss the lab.shake right now?
Yes, if you want.
Okay, and then we'll have Yorgos after. So, do you want to move the slides yourself, or do you want me to
Oh,
move them?
you can move it. You do it very well.
I can move it. Okay.
So I just took a presentation that is longer because it's what we did during the inauguration of the LabSchick, which occurs 2 or 3 weeks ago. So if you want to access all the talk, you can. It's on YouTube, and so you can have it and enjoy my very nice English accent I have for this talk. Otherwise, so the LabSchick. So next slide, please. So I will talk about the LabSchick, which is an initiative from Activity and IMT Atlantic. And if you go to the next slide to explain a little bit the what is the landscape. So we have Activity, which acquire a Clio, and so get some two products that are doing Chic. One is the IP core, that is, as its name says, on the core network, and is very scalable and can process a lot of Chic flow at a time. And on the other side, we have the full SDK, which is the Chic part for embedded systems, embedded devices. And we have on the other side something that is done by the community and now mainly managed by IMT Atlantic, and is OpenSCHC. That is not in the same situation regarding the documentation, the way it is implemented, but it's very useful to test a new feature or to learn how SCHC works. Yes, Pascal?
The one thing I did not understand from what you're saying, and I think I know the answer, but just to make sure, the open source is actually not the old open source we had, but you're talking about the Aclio implementation of SCHC, which is now going open source, right?
Yes, but its current situation. So it was before the LabSCHC, so we have this situation, and IPCore and full SDK were Actility product.
Oh, so this is not currently, this is before.
Currently, yes, it was for the inauguration, so it was before they signed the document.
Okay.
Sorry about that. So, and what we do next, so next slide. So the goal now is to have this LabSCHC that will handle the full SDK part. And so the goal of the LabSCHC will be to maintain compatibility between IPCore for commercial product and also OpenSCHC for more research and development products. And so this is this part, full SDK, that will be released in open source. So next slide. So here it gives a little bit of what we will do during this year. So we have Alex, not Alexander Pelov, but Alejandro Fernandez, that is working on the product from the IMT part. And now what we are doing is to take control of this full SDK and make it compatible with IPCore and OpenSCHC. So our first objective is to release the first version of full SDK in June, end of June, to do test, and also to go to Vancouver and go to the hackathon and test it. And the other thing also is to see how we can develop and integrate to this environment new feature. And one that looks very interesting and promising is the FEC. So the goal will be to add FEC in OpenSCHC and full SDK. And the full release of the code will be at the end of the year with all the features that were present in the full SDK. So maybe I let Alex talking about what we have inside the full SDK. So you have to click on the mic to talk.
Yeah, I thought Pascal wanted to say something.
No, I don't have a question. So.
Okay, sorry. Yeah, hi everyone, I'm Alex. So I've been working on the embedded systems library for SCHC. Can you move to the next slide, please? So just to quickly tell about what this is about. So far I've been testing this on 2 boards with more success on the STM32L0 board. So the one that is highlighted up there. And where it uses the SX1276 transceiver. And there's another board that's theoretically supported, but I didn't have much success building for it. So maybe I'm using the third shield, lower shield. I haven't tested with the other shields. So for now we'll be testing on this one, and it's the platform that I'll be focusing on. Next slide, please.
Yes, I will. Just to make sure, are you speaking very, very close to your mic? Because I have trouble understanding you. It seems that your mic is saturating a bit on my side, actually. And so I just wonder if you could move the mic a bit farther from your mouth.
Okay, let
Maybe
me see if
this
that's better.
would be better for us than I'm moving slides.
Is that better?
Yes, it seems better.
Okay. Okay, and for layer 2 stacks, well, the library comes with a lot of layer 2 libraries, namely Semtex LoRaWAN, LVM, Sigfox, and VOT. So far, I've only tested with Semtex according to the Semtex stack, according to the board that I'm testing with. But yeah, in theory, eventually at some point, I will be able to test for other platforms and other layer 2 stacks. But for now, we are focusing on the Semtex one. And next slide. So far, I've actually managed to make a small derivative of the library, and I've managed to make a compression-only example running with OpenShift. They both communicate with the same application server app. So that's super cool. And next up, I will test the fragmentation and reassembly part, and then I'll start to release the GitHub repository as per the roadmap, of course. Yes, Pascal?
Yes, then again, I have the same question just to understand when you mean the full SDK, does that include the original SCHC implementation by Aclio, or do you replace it with the OpenShift Python implementation, or what's the deal about SCHC?
Yeah, LabSCHC full SDK retakes the code released by Actility, and what I'm doing is making sure it's compatible with OpenShift, with the Python stuff, and at the same time, it's compatible with Actility's IP core. So it's really the same product. I'm making sure now I'm maintaining it and making sure it will be compatible with OpenShift. So I'm taking away a bit the proprietary parts developed by Aclio, which is Actility now, so that it can be released and tested by anyone who can use also OpenShift as a core. Does that answer your question?
Yeah, I mean, I understand. So when we download the open source in the future, we'll have the implementation by Aclio stripped from the proprietary things. And I just wonder if there's a chance that some of those proprietary things would make sense for the rest of the community, and why not, right? In which case, the alternate could be to either to write some draft about them or just to leave them. I mean, or is there some secret sauce that you want to keep? Is that what you have in mind?
Not really, but it's precisely this, the fact that there are some proprietary stuff that are not yet necessarily part of the standards. So if it gets discussed, the implementation is already there, but the objective is to slowly release the code and complete the, let's say, the empty spaces in the standard accordingly. So not necessarily by enforcing a given solution that's already implemented as a standard, you know.
Okay, thank you. And then it's obviously a great news to have a high quality open source implementation available in open source. Certainly. Thank you so much for doing this.
Yes. Just to add that if someone wants to join us and work on that, we are fully open. And the goal is not to block things, but to understand them before releasing them, because if we don't have don't know how to use them, it can be not efficient.
Yep. And finally, there's more information on the website. We've released a website. I didn't put the link on the presentation. It's
lab-chic.fr. Pascal, I don't know if you can share your screen on this website, or you can just visit it on your site.
Well, since I'm presenting from here,
I will put them on the notes.
I could do it, but I would have to do a number of things before that shows. Lab.chic. You say lab.chic.fr?
Dash.
Lab-chic, okay. Okay, and now I can share it. Do you see it now?
No, but
okay, I just authorize it. It says being started, but it doesn't seem to do it.
Doesn't matter.
Well,
we have the link, so go to the site.
Yeah, it says it's being started, but it doesn't really something. Oh, maybe it's some JavaScript. I don't know. Okay, it just doesn't work. It says I'm showing Firefox, but I don't know if you're not seeing anything. I will just stop it. So lab-chic.fr. You have to try it yourself.
Yep, I've put the link on the messages. I think it is on the chat. But other than that, that's all from our side, and we'll see you at the IETF hackathon in Vancouver.
Very nice. Looking forward for all this. And then I will share Yorgos' slides. I see that Yorgos has joined now. So let me share. Yorgos, do you want to move them yourself, or do you want me to move the
Hello, Pascal. Hello, everyone. It's up to you. I mean, you can move it, please.
I can move it? Okay.
Do you hear me, actually?
I'm sorry?
Do you hear me? Do you hear me well?
Yes.
Yes. It's very good.
Okay. Shall I start, or?
Hey, go ahead. The floor is for you.
Thank you. Hello, everyone. Georgios Papadopoulos and Amaury Bruno from IMT Atlantica. So this is the FEC for SCHC framework draft. I mean, the FEC that Laurent was talking right before. Thank you, Pascal. So the SCHC framework, as can be known, can be applied over lossy radio links such as LP1, where some of the fragments of a SCHC packet can be lost, which may lead to a failure of the reception of the whole SCHC packet. Notably in the case of NOAC mode. So by employing FEC into SCHC allows the destination node, the receiver, to increase the chances for the destination node to recover the missing SCHC fragments without the need for the sender to retransmit the missing SCHC fragments again. Next slide, please. So regarding the FEC principle, FEC is a method employed to control errors in a packet transmission by employing additional redundant information within transmitted fragments, thereby reducing the chances for the receiver to request retransmission of missing fragments. Now, FEC can be classified into intra-frame, where error correction codes add redundancy inside a packet to correct errors on individual packets, and interframe or interfragment, where additional redundant frames or fragments are transmitted. So for example, in LoRa technology, we have the intra-frame FEC that uses coding rates from 4/5 to 4/8. However, in this document, a generic interframe FEC mechanism is presented to obtain higher data delivery rate. Next slide, please. So XOR FEC employs the exclusive OR or XOR operator within its FEC mechanism to produce an extra fragment for fragmented SCHC packet. This supplementary fragment contains redundant information, and it is sent after the original fragments of the SCHC packet. As a result, it allows the receiver to detect a potential loss of an original fragment to recover it. Now, mitigating thus the scenario where the loss of one fragment leads to the entire packet being lost, or to reduce the number of fragment retransmissions. Next slide, please. Now, the key property of XOR used in XOR FEC for fragment recovery is that by applying XOR to the result of an initial XOR and the one of its input values, the result will be the other input value. So to give you an example, if a SCHC packet is fragmented into two fragments, A and B, the additional fragment C generated by the source node, the transmitter, will be C equal XOR B. Now, in this case, if the receiver receives the A and C fragments, but does not receive the fragment B, it can recover the B fragment by applying XOR operator to the successfully received fragment, as can be observed in the last equation. Next slide, please. Now, to generalize this procedure on SCHC packets that consist of more than two fragments, so with key original fragments, K original fragments from F1 to Fk, the additional fragment F additional will be equal to XOR of all these fragments of the original SCHC packet. Now, if the receiver receives successfully all fragments except Fi, for example, then it can recover the latter by applying XOR operator to the successfully received fragments, as can be seen below. Next slide, please. So in the following, we have three examples, one example per fragmentation mode. Next slide, please. So here we have the original example from the RFC 8724 of no-AG fragmentation mode, where a SCHC packet is fragmented into 5 SCHC fragments with FCN equal to 1 bit. And as can be observed, all 5 SCHC fragments successfully are received by the receiver. Next slide, please. Now, considering the previous no-AG mode example, but let's assume now that one SCHC fragment is lost, the third fragment. In this case, the XOR FEC is applied to all 5 SCHC fragments. Next slide, please. And as can be observed, even if with no-AG mode, there is no feedback from the receiver, by employing XOR FEC, the receiver may successfully reassemble the original SCHC packet. And as a result, the network reliability is increased for a certain range of loss or error rates. Next slide, please. Similarly, here we have the example of AG on error mode of a SCHC packet fragmented in 11 tiles that is adapted when XOR FEC is applied per window. So this is another example from the same RFC. So in this example, there is 1 tile per fragment, thus additional 1 fragment, the redundant fragment, is introduced per window. And furthermore, the FCN size is equal to 3 bits, the window size is equal to 7, and we consider in this case that we have 2 lost SCHC fragments. Next slide, please. As can be observed, even though 2 fragments were lost, the 5th and the 9th fragments, they were recovered thanks to the additional XOR fragments. And as a result, thanks to the XOR-FEC, the communication is reduced by 2 transmissions. Next slide, please. Here it can be, so this is the original example of ACON error, and it can be calculated. Here we have 16 total transmissions when we have 2 fragment losses. So we have 14 versus 16 transmissions. Next slide, please. So finally, here is the adapted ACK always example when XOR-FEC is applied. As previously, a SCHC packet is fragmented in 11 tiles with 1 tile per SCHC fragment. FCN is equal to 3, window size 7, and we have again, as an example, 2 lost SCHC fragments. Like in ACK on error mode, in ACK always, the XOR is applied per window, and 1 additional XOR fragment is introduced per window. Next slide, please. And once again, as can be observed, even though 2 fragments were lost, the 5th and the 9th, they were recovered thanks to the additional XOR fragments. And as a result, thanks to the XOR-FEC, the communication exchange is reduced by 2 transmissions when compared to the original example, which we will see in the next slide, please. And here is the original version from the RFC 8724, and as can be calculated, there were in total 17 transmissions with 2 fragment losses. Next slide, please.
Yorgos, if I may, it's not just the number of transmission, but the fact that we are trading upstream transmission as well. Even if we do a bit more upstream, it's a win if we can save downstream.
Yes,
And
yes.
so,
I didn't go to the details. I mean, because of the time.
But it's a huge value in this case. When you say you save 2 messages, you actually, one of them is a downstream, which is great.
Yes. Thank you. Thank you, Pascal. So this is the takeaway and road forward slide that we prepared. So from the little that we worked so far, FEC makes a lot of sense, especially in the NOAC mode. Why? Because there is no feedback from the receiver, and by employing XOR-FEC, the receiver may successfully reassemble the original SCHC packet. So this is, I mean, for my humble opinion, quite great to have. While on the other fragmentation modes, as Pascal said as well, yes, we're reducing the number of fragment retransmissions and the downlink here as well, which are required to avoid the entire packet being lost. So this is the first point, which is the advantage. And then we have the drawbacks or the limitations. So the main limitation is that the XOR-FEC algorithm it has loss tolerance of 1 missing fragment. And the second is that as it is straightforward, while SCHC mechanism increases the network reliability in the lossy networks, they also introduce additional costs since sending additional redundant fragments demand energy and bandwidth. And the last part of the slide is the road forward. We have defined the XOR-FEC, well, FEC based on XOR algorithm, but we didn't yet touch how to formalize, how to signal that a data unit, a XOR fragment, carries the redundancy. So we are at this stage. That's it from my side, but from our side. Thank you, Pascal.
Well, thank you very much. Yorgos, do we have any question? I see that Laurent has still his mic on. Do you want to speak, Laurent?
Yes, thank you, Georgios, for this nice presentation, and it's a very good starting point for introduce FEC. It's something very important. I have 2 questions. One is that you are using here only XOR. That's but there is, for example, in CD, DVD, you have other kind of FEC that can be used. So can it apply also to this mechanism?
So this was one other point that I didn't put it at the end. My question what I wanted to ask you is that so far we have one algorithm, and the question is whether we want like n algorithms to present. Yes, so we can. What I'm trying to say, yes, we can study other FEC algorithms, and we have in mind 2 more with Amaury. But I was thinking, like, let's start with one algorithm to make clear the story, and then we can build on top of that. Yes.
Okay, and my other question is that when you do FEC, is it only at the fragmentation layer and the FEC is removed when you send the data to the decompression, or how you manage to process the original packet without FEC?
Not sure if I understood the question.
You introduce some FEC, you add some extra packets in your flow.
Yes.
And how you remove them?
You mean remove on the receiver side, or what do you mean remove?
Yes, on the receiver side, because if you send something, you make it more stronger with FEC. But if it's the receiver doesn't understand the FEC after that, then it can be viewed as error.
Yes, we didn't treat this part, Laurent.
Okay.
Yes, we didn't treat the formalization, as I say in the slide here. This is what the point actually. We didn't treat how to signal this.
So just so for me, this is very good starting point, as I say, and I think we have to play with FCN value and say, for example, if we have n among the FCN, or FCN modulo 3 is a computed frame, then maybe we can solve this problem.
Thank you. Thank you. This is the question actually that I have at the end. Like the last bullet point is exactly this.
And the last point is maybe we have to check with Sergio, because we can have streaming and FEC that can be combined. Maybe it's complex, but we have to see.
Yes, this is we discussed very lightly with Alex a long time ago, but yeah, it will be great to discuss it, to start again the discussion.
Thank you.
Thank you.
Okay, I'm not hearing any more questions. So yes, I mean, this is certainly a beginning with FEC and based on XOR. And I believe that we need one simple mechanism that is the default. And in the future, if you want to define more mechanisms, what I thought about dynamically changing the FEC is if we can dynamically change the window size, then and we say that the last element is always the FEC, element 0, basically, FCN equals 0. Then basically just by tuning the window size from 7 here to 3 or 2, then you increase the amount of FEC dynamically, and that doesn't have to be negotiated, and you don't have to tell, oh, I'm going to do 2 FECs in one window or something like that. Just change the window size. Could be one way.
Oh, that's nice. Yes. Yeah. Good point.
Just one point, Pascal, on forcing an algorithm is not what we did with SCHC, for example, for the RCS. We say, look, you can take the Ethernet CRC, but you have the possibility to do something else, and it is reflected in the data model. So I think
I don't mind that. I'm talking about implementations. I guess there should always be at least one thing that all implementations should have, and it's probably XOR because it's very, very simple. And then the data model could allow for more, but then you need some negotiation to say, hey, both implementations support.
Thank you very much for the inputs. They are really, really, really useful. Yeah,
okay,
and dynamic. I like this dynamic window. Yeah. Thank you.
Okay, so I guess we are at the top of the hour. So I thank you all for those great presentations. Thank you, Yorgos, for taking the FEC work, finally taking it and moving it already very fast. And with this, thank you all for the meeting. Just one question to Eric. If Eric, you're still there, how can we access the recording of this meeting? It's on YouTube, or because we had some people who could not come, would like to hear what we said.
Yeah, so I'm still there, Pascal, and hello to everyone. I guess it will appear in Data Tracker at the very same place where you can find all the minutes and the material from the meetings. Maybe the best is to take this offline. Then we can have a quick look.
I guess that's my answer. So yes, because Carlos asked and Alex is not with us either. So if they don't know it already, I will let them know. Thank you so much, Eric.
You're welcome. Great day, everyone.
Thank you all. Bye-bye.
Bye.
Bye.